Yo, what's up, friends? I'm sorry I'm not with y'all today. My daughter is sick. Although she's not acting like it right now, but she is sick. So, y'all, I want you to watch this. It's about scientific notation. It's what we're learning next. We just learned about exponent rules. You should know all the exponent rules by now, all of them. And we're going to now apply those to stuff that you might encounter, say, in the real world. Now, not all of you would probably use this in the real world, but this is how we apply it to other subjects as well, okay? Some of you are like going, scientific notation, what are we even doing with science? Like, why are we talking about science? Well, a lot of science and math are intertwined, all right? You can't do science without math. You can't have math without science because both of them dictate the world around us. Scientific notation is an expression that represents a really big or really small number. Alright, we're going to talk more about this tomorrow, but, okay, I keep using those days. We're going to talk more about this later, but an expression that represents, that says represents right there, a really big or really small number. So when we talk about that, let's say we're talking about the distance from here to the sun. Hold on. Just talking. Let's say we were talking about the distance from here to the sun. All right, so we're talking about a really big number. That number actually is 97 million miles. Okay, now that's a very big number. Sometimes, what if we were talking about how far away is the sun in inches? I mean, you would have a crazy big number. And what happens is if you leave off of 1 0, it might not seem like that big of a deal, but when you're talking about numbers that big, it is. We'll talk more about what a big deal that would be later. If you just left off a 0, it's like, oh, well, it should have been 12 zeros. I put 13. That's no big deal. That is a huge deal. Okay, so we have 97 million miles. There is a chance that you could add on another 0 or leave one off. So we want another way that we could represent 97 million, but in a way that would be less chances for us to make a mistake when we were writing it down. Another reason why we'd write a number in scientific notation is because we can then add, subtract, multiply, and divide another really big number. And you can do it a lot easier that way. So let's take this, 97 million. What we're going to do is step 1. You, my friends, are going to write, if there's not a decimal, you got to put it there. But you're going to move the decimal in the number to make it between 1 and 2. Okay, so the decimal in the number 97 million, it's all the way here at the end. We're going to pick this decimal up and we're going to put it somewhere in that number that would make it a number between, that says 2, I'm sorry, 1 and 10. All right, now the stipulations for that, let's say the number where we want to move the decimal to, it's got to be a number, let's call it A, that is greater than 1, greater than or equal to 1, but just greater than 10. And what that means, you can't have the number be 10. All right, it's going to make sense in a little bit, in just a little bit. We're going to move this decimal in the number to make it between 1 and 10. So if I put the decimal right there, that'd give me 970, okay, because we don't need these zeros after that, okay? So is 970 between 1 and 10? Obviously not. So, wait. Yeah. Okay, so we're not going to put the decimal there, yeah? We are going to move that decimal to make it a number between 1 and 10. So if I move it right there, it'd be 97. If we moved it one more time, it'd be 9.7. So that is a number between 1 and 10. That's the one we're going to want to use. So you're going to say 9.7, right? And we're going to always say times 10, and we're going to raise it to a power. How many times you move the decimal is how many times you move the decimal is what your exponent for 10 is going to be. Because when you move the decimal, deci is Greek, I believe, for 10, you're moving it by a power of 10. So if I moved it one time over, you get 9,700,000, which is not the same thing as 97 million. But if you multiplied it times 10 and however many times you move the decimal, you'd have the same thing. We move the decimal 1, 2, 3, 4, 5, 6, 7 times. You'd put times 10 to the 7th. And this is the same number written in scientific notation. That's a 7. Okay. Notice we did not just put however many zeros. We didn't make that the exponent. We didn't say 10 to the 6. All right. You don't just look at the zeros. Okay. Let's look at another one. So this second step, I guess you could say. Let's see how we're doing on time here. Oh boy. Insert page. Okay. Let's say we have the number 540,000. Not too big of a number, but we're going to make it a number between A, and it can be greater than, or we want A to be greater than or equal to 1. It's got to be a number greater than 1, less than 10. Okay, it's got to be a number between 1 and 9.99999, repeating. All right, so there's not a decimal in the number 540,000. Put my decimal right there, and I'm going to move that decimal. That was step 1. In between the two numbers that would make it between 1 and 9.999, I get 5.4. If I moved it here, it'd be 54. Not a number between 1 and 10. Not a number between 1 and 9.99. So we moved it in between the 5 and the 4. And step 2 would be how many times you move decimal is the exponent for 10. Alright, so let's think about this for a second. I'm always going to be multiplying times 10, and however many times I raise the power to, that's what the exponent would be. Because, like, let's say 10 to the third, that's 10 times 10 times 10, that's 1,000. Well, this number is 540,000, so it's got to be an exponent greater than 3. We moved it 1, 2, 3, 4, 5. We moved it 5 times, and we have 5.4 times 10 to the 5th. That is another way of representing the number 540,000. Alright, let's take another one. So what we did is we wrote that number in a way that it will be easier for us to use, okay? Now, one of the stipulations was it's a really big or really small number. What if you had the number, like let's say the length in inches of the cell wall of a flower or something like that, okay? That is a very, 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 very small number, okay? There's a chance we could leave out or add an extra 0 and it would completely change the number, so it's a big deal. You want to move the number in between, you want to move the decimal in between the two numbers to make it between 1 and 10. So if I move the decimal, if I put it right there, it'd be 0.09, not a number between 1 and 10. If I move it over one more time, I get 0.9, not a number between 1 and 10. But if I move it over one more time, I get 9 or 9.0. Either way you want to look at it. That's good. That's a number between 1 and 10. Now, we'd say 9 times 10. Now, we wouldn't put, let's see how many times. 1, 2, 3, 4, 5, 6, 7, 8. We moved it 9 times. This is incorrect because 10 to the 9th is a huge number. This is not a very huge number. We're talking about the length in inches of a cell wall, you know, for a flower, okay? You would say 9 times 10 to the negative 9 because remember, negative exponents are not negative. It's another way of writing a very small number. I want to show y'all one more thing. Nope, that's not what I wanted. Let's see another page. So we got the first number by moving the decimal, make it between 1 and 10, and we got the exponent by means of how many times you move the decimal. Now, This is a very huge mistake that kids make. And if you listen to nothing else today, listen to this. I have never said once, if you move the decimal to the right, it's a positive exponent. If you move it to the left, that's a negative exponent. It doesn't work like that. If there was a rule, I would give it to you. I'm not going to make your life harder than it needs to be. Alright, if there was a rule like move it to the left, make it a positive exponent, move it to the right, make it a negative, it doesn't work like that because sometimes you go forward, sometimes you go backwards. This one, we're going to go backwards. 3.7 times 10 to the 9th. Or let's just say 10 to the 8th because we used 9 already. Well, what you need to ask yourself is, is this a big number or a small number? Well, I mean, how do you determine that? Well, 10 to the 8th, is that a big number or a small number? I mean, that's a 1 with 8 zeros behind it. That's a huge number. If that was a negative 8, now you're talking about a very small number. It would be a very small decimal, okay? We're going to move the decimal in the direction that gives you a big number. If this is a big number, you want to move the decimal in the direction that gives you a big number. I've never once said, oh, it's a positive exponent, move it to the right. Because if you're going the other way around and you had a positive exponent, or if you had a really big number, you'd be moving it to the left. It doesn't work like that. It's going to confuse you. You have 3.7. You know it's going to be a big number. If I move it to the left, that's going to give me a crazy small number. I want to move it to the right. I'm going to move it 8 times. I don't just add 8 zeros. I'm going to say 1, 2, 3, 4, 5, 6, 7. I got to go one more time. And the decimal goes at the end. All right. That number is, let's see here, 370 million. All right. Very big number. So don't look at it as, I'm going to move it to the left. It's positive. Move it to the right. It's negative. So you're going to move it in the direction that gives you a big number. All right. So if you had 6 times 10 to the negative 2, well, the decimal number 6 is at the end. If I move it to the right, I get 600. That's a big number. If I move it to the left, I get 0.06. Which one of these should I get? Because how do we determine it? We look at this exponent right here. If it's positive, you get 600. If it's negative, you're going to get a crazy decimal like that. Guys, we're going to talk about it a little bit more tomorrow. Y'all get that done. Please be kind to Miss Carter and do the next right thing. I believe in you.